Hey, welcome back to the third part of the Jumpstart today on Windows 10 Technical Preview. We're now going to take a look at security and drill down into that subject area with Chris Hallam. Chris, welcome to the NVA studio.
Great, thanks for having me. I appreciate the time.
No worries. So we're going to have a look, I guess we're going to start off around why Windows 10 is going to be really good from a security aspect. Can you just give us like the very high level on that to start off with?
Sure, absolutely. So when we think about security and we look at like what we've done in 7 or Windows 8, 8.1, I think what we've done is we've done a really good job implementing defense in depth. We added more and more protections and kind of walled off certain areas of the system that were vulnerable to certain types of attacks. But what's different about Windows 10 is we're actually delivering architectural changes that in many respects eliminate entire risk factors altogether. So as opposed to the past where we just add another defense, it made it a little bit harder for the bad guys to break into systems. We're changing the way the system is designed in ways that actually eliminate the attack vectors entirely in some cases. And so I think that's really one of the big differences when you look at 7 and 8 and compare it versus 10 is that architectural shift that we're making in the platform itself.
So we're trying to make it into a very, very compelling security story to want to move on to 10 so that we really do get to have all of those great experiences that we may have seen added in 7 and 8 and also entire new architecture that's coming in 10 as well.
Yeah, absolutely. I mean, this release from a security perspective is substantial. In my personal opinion, is everything that we've done in XP all the way to 8.1. I think not necessarily in code or how many features have been implemented, but in the impact that this platform will have. It's like almost everything we've done in the past in a single release. And it makes sense because if you look at the resource allocation and the type of things that we've put to bear on security for this release, it's a big effort, but it's something we feel we can do. So.
Cool. So you've seen on the slides that folks can see, we've actually got the whole place kind of split up into these 3 buckets: identities, securing identities, information protection, and the actual threat resistance of the operating system itself. So I guess you want to start off with secure identities and kind of give us something to think about there.
Yeah, absolutely. So when we think about identity, identity's become kind of today's crisis. It's not the crisis that's coming down the road. It's the crisis we're living in right now, and that crisis is related to passwords. Yeah. And so passwords are deeply embedded in the systems, on the web, on PCs, on mobile devices. We use passwords everywhere. But as we've seen, they're increasingly being targeted and stolen. And the challenge with a password, of course, is it's a network secret. Mm-hmm. So and it's also a single factor. And so if I can get this string of text from you, or maybe if I can guess it, I can become you anywhere on the network, on-prem here at Microsoft, or maybe remotely from another country, et cetera. So we need to move to a 2-factor authentication mode, meaning I need something that I have, or something that I am, or something that I know, the combination of these 2 factors, which will prevent my secret from being used across the network like we have with a password. So with Windows 10, what we're saying is we're ushering in the end of passwords. And I like to underline the word usher, mm-hmm. because I can't turn on a switch in Windows and on the web and suddenly passwords disappear from existence. It's not that simple. But what we've done in Windows 10 is we've implemented a solution in the platform itself so that we can usher in the end of passwords, that everything that you need to move to 2-factor authentication for consumers, for enterprises, is all there, and it's just a matter of adopting the technology by bringing the platform into your environment and up to web services on the internet to adapt to this new method of authentication.
Yeah, and we're seeing that we've actually, as you say, we're making it so that there can be different factors of authentication built in here. So it could be, I guess, you could receive a phone call, for example, and that could be the second factor, or presumably as well placing it into, I don't know, the TPM chip on a device, so the device becomes the second factor.
Yeah, absolutely. So what we've had in the past with 2-factor authentication solutions were solutions that were pretty expensive, to be quite honest. It required the use of another product, meaning maybe a smart card, maybe I use an RSA token, but there's something that I bring, something physical that I bring with me. And the challenge with these types of authentication options is that second factor is something that I might leave behind. I may, with a smart card, I may leave it at my home PC stuck in the smart card reader, or it can break, you know, and it's just this other thing that I kind of have to remember. But what if we could take the devices that we always have, the devices that we use, and we could make those the second factor? Well, with our next generation credential technology that we're shipping in Windows 10, we'll be able to do just that. Your PC, using the TPM that you mentioned a moment ago, will allow us to create a credential and physically bind that to a PC, and in so in many respects, the PC itself that you're using is the second factor. And so that's one option, but there's a better option, and that option is to use your mobile phone as a mobile credential. So if you're an IT type of person, chances are you use many devices in your network. You wouldn't want to enroll your credential in each and every one of those. Wouldn't it be great if my credential was on the thing that roams with me all the time, my mobile phone, and then as I log into a server or log into this PC or that PC over there, that it actually uses my mobile phone as my second factor when I authenticate. And of course then the first factor will be either a PIN. So we're moving away from the semantics of passwords. PINs are very similar to passwords. They're a string of characters, but the thing that's different is this PIN is backed by that physical factor, that second factor that makes it stronger than a password, which is always a single factor authentication. So we use a PIN, and again, it can be alpha or numeric, or a combination of both. And then the other option is to use biometrics. And so we're big fans of biometrics, and we believe that fingerprints are an excellent way to authenticate. They have the characteristics from a security perspective to be great for authentication. And in many respects, they're better than PINs and passwords because they can't be shoulder surfed. It's very difficult to recreate my biometric information and spoof a biometric sensor, for instance. There are things you can see on the internet where people have successfully spoofed many of these sensors. Most of these types of examples are not, I think, real use cases that you'd see in the wild. In the example of the fingerprint spoofs that you might see, you'll find videos where somebody recreates a fingerprint. But what you'll see in those videos is also they're recreating their own fingerprints. So they're in control of their print. They're recreating it using expertise that they have, and they're able to spoof the sensors that way. That's not the attack we're worried about. You don't need to break into your own device. The attack we're really worried about is when you leave a latent print on a surface, maybe the mobile phone that you've lost, or a beer mug at the pub, or whatever. If somebody can lift that and recreate your biometric identity and break into your device with that, then that's something we get worried about. And the sensors from many of the vendors we're working with, they're not susceptible to those types of attacks. So it's really latent prints that we're worried about in the spoofing scenario, not people recreating their own biometric information and breaking into their own devices.
And I guess as well, you would still, even if you're using biometrics, you should probably still be thinking of those as a second factor of authentication or part of a two-factor authentication process. Anyway,
absolutely.
It's not just about the fingerprint; it's about the fingerprint and the PIN.
Oh, absolutely, yeah. It's a fingerprint and the device, actually.
Yeah.
So the combination of the PC and the fingerprint make it very, very difficult to break into a device. And again, just to emphasize the weakness of passwords, even if you're able to take my biometric information, let's say you were able to recreate it, you could not use it remotely. You would still need to steal my device. Yeah. So you need a bunch of things to make this work, and that's why the bar is so much harder to jump across when we move away from passwords to these other options. Because yes, while technically there are risk factors and there are attack vectors that we need to be concerned about, what we're moving away from is so inherently insecure comparatively that even if we're faced with some weaknesses, we've still got something that's far, far more secure than what we're using today.
And it's not just about building the authentication mechanisms on the device either. It's also about building the authentication mechanisms on the services side. So things like Azure Active Directory coming around as well, being the authentication point, is quite important for us.
Yeah, absolutely. So the work that we've done on the client side is just one part of the equation, right? The other thing we need is the authentication systems, such as Active Directory, Azure Active Directory, and even Microsoft Account, actually. They are all adopting this new technology. And so when we ship Windows 10, if you're a consumer and you're using your Microsoft account to sign in your device, if you'll be using actually two-factor authentication option, and you probably won't even realize it, right?
Yeah.
And which is great, because that's kind of what we're trying to achieve. We want all the convenience of the password, but we want all the security of a smart card or an enterprise class solution. And so the consumers are going to be able to make this transition very easily, because it's really going to be happening in behind the scenes. Windows is going to be doing most of this work, and they'll end up being more secure in a way that they may not have realized.
Yeah, and one of the things that we're doing as well is we're making it so that you can just log into your Windows device with Azure Active Directory credentials, which will obviously then be federated or synchronized with your on-premises Active Directory credentials as well, most likely. But it's a very subtle move, but it's very important, because it means that consumers can sign in using a Microsoft account, but enterprises sign in with something they already know, their Active Directory credentials.
Yeah.
Onto those devices.
Yeah, absolutely. You know, with Windows 8 and 8.1, you had the ability to use a Microsoft account to sign in, and that was great, right? I mean, as a user, I'm using an online account, and the second I sign into Windows, all those Windows services work right away. I never have to sign in again, in theory. So that's great. And when I use a domain account, I have the same type of benefit, but a lot of our customers are really looking at Azure Active Directory to solve a number of problems. And now you'll be able to sign in to a device using an Azure Active Directory account, just like you've already been doing with domain accounts and Microsoft accounts. In fact, there's a customer that we've talked to. They're thinking of Azure Active Directory as a means to simplify and strengthen their security in their organization. There's a whole class of users on their network who really don't need to be domain joined or connected to the network. They need access to a limited set of resources, but those can be made available through like web proxies and these types of things. And so what they're going to do is they're going to move that large group of users, and it's actually tens of thousands, off of the domain, and they're going to use Azure Active Directory in Windows 10 as a means to authenticate those users and manage those users and keep those devices that don't need to be on the network, the corp network, off of it. And so that'll really enhance their security, enhance the manageability, and simplify even the provisioning of these devices to their users, because they just don't need as much configuration when they're not connected to the domain. And so while that's not something we recommend for all all users, there are certain classes of users within most organizations that could probably move to that model, and so we think it's a great idea.
Yeah, it's a good idea to start thinking slightly differently about the way that you're using your accounts, particularly when you get that flexibility that Azure AD actually starts to give you as well. In terms of thinking about protecting enterprise credentials, we're building some things into the operating system there to allow isolated tokens inside of containers and those kind of things. Can you just talk us through some of that for a while? Yeah,
absolutely. Yeah. So this is the great second part of our story. So the first part, of course, is the authentication factor, right? So the next generation credential allows me to prove my identity in a secure way. It's two factors, right? And that's good news. But there's actually something that happens after authentication that we also need to make improvements in. And so when you sign into the network and get authenticated, your identity provider is going to issue to you some sort of ticket, right? And this ticket, this hash value, et cetera, this is what allows you to go to all the resources on your corporate network, whether it's SharePoint or a file server or even to another client. And you don't need to authenticate again, right?
Yeah.
You've got this token allows you to be you for this period of time. Well, what's interesting about that is if I'm an attacker and I steal those tokens, in a way, I have your identity, and so it's just as bad as having your username and password stolen. It's just as bad having your tokens stolen. And in fact, what's interesting about when you steal a token is you don't even need to know the user's name or password, because you have their access,
the actual token,
the token that they use to connect, and all the machines on the network will trust that token for its life cycle. So this is an attack type that's being used quite frequently. It's typically coupled with advanced persistent threats, APTs, and the attack type itself is called a pass the hash or pass the ticket type of attack. And so with Windows 10, In fact, actually, with Windows 8, we implemented a bunch of mitigations that made it a little harder for the bad guys to get access to these tokens. But the reality is without an architectural change of the system, we really couldn't completely protect or mitigate this attack. So it was, again, kind of a defense in depth. Let's make it a little bit harder for the bad guys to get access. Let's frustrate them, but it wasn't really a final solution. And so with Windows 10, we deliver a final solution, architectural change that actually eliminates architecturally the attacks as they're currently being implemented. And so what we'll use Hyper-V technology. There's virtualization extensions in Intel processors, and AMD has the same types of processors extensions on their 64-bit processor lines. Yeah. In the case of Intel, I think it's called VTD or whatever, the virtualization extensions. But at any rate, what we're able to do there is spin up Hyper-V, and we're able to put what we call min core of Windows in that virtual environment. So the PC is going to boot, and the operating system that you're used to using is going to boot, but in parallel, we're going to boot a minimum Windows Core operating system. And within this container, this protected, isolated environment, we're going to put the LSA service. And the LSA service is the authentication broker that handles authentication for Windows. It also is the tool that has, or the service that has access to these tokens we just talked about. The tokens themselves are going to be inside this container. So we're going to have the service for authentication as well as all these tokens inside of this container that's isolated from Windows. And so then in the event that Windows experiences some sort of vulnerability, let's say, that gives an attacker or malware the highest possible level of privilege. So let's say I'm owning the kernel on the device. Yeah. Well, the kernel on the OS that you're running doesn't actually have access to anything running in the container, right? It's completely isolated. So I can't extract these tokens out of the container because they're inside there and they can't be physically removed. So this is, again, an architectural change that eliminates NTLM pass-a-hash attacks as we know them today, as well as Kerberos ticket type passing attacks as well. So this is a very, very strong mitigation against an attack that used to be theoretical, that is actually become weaponized and is being used in a mainstream way. In fact, if I'm an attacker breaking into a network, I can't imagine not using this attack, because it allows me to become any user I want in theory, if I'm able to get those tokens off the right devices. So.
Yeah, and if you want some information on how to be able to mitigate pass-the-hash attacks in your current environment, take a look on side of MVA. We've got some really great jumpstarts around defense in depth that will really help you with that kind of thing. So it's a great place to be thinking about and looking towards as well. Keep the questions coming in over on the Q&A. We'll make sure we try and answer as much as we can. Obviously, as we've said a couple of times, Windows 10 is a work in progress. We are building it, and there's some things we can't talk about right now. So as long as the questions that you guys are asking are things that we can talk about, we'll get them answered for you. And on the feedback, again, just to reiterate, don't give us feedback on the products inside of the Q&A. That's what the user voice forums and the tool inside of the technical preview are for. So as we start thinking about the next kind of pillar of the story, the information protection pillar, that becomes kind of really important for us as well, preventing, I guess, data leakage.
Yeah, absolutely. And so we've had some great technologies in Windows for protecting data for a long time. But we have a lot of those technologies, and that was kind of part of the problem we had in Windows 8 and 8.1 is how do I piece together all these disparate parts, and which ones should I use under what conditions? And so the best way to kind of simplify the story is like this. So we have BitLocker, which is an exceptional technology for protecting data at rest. And it's easy to deploy with Windows 8.1, and it's very mature in the marketplace from a competitive standpoint. It's become increasingly attractive for organizations. So we've got data at rest protection, but the problem with data at rest protection is it only protects data at rest, meaning on the device. And so the second that data moves off of the device, I no longer have the benefit of encryption, right? It travels in the clear. And so we have a solution on the other side, which allows data protection to travel or move with the data. And we call that technology rights management services. And there's Office IRM, which is built on top of RMS to add persistent file-level encryption around documents and other types of files. And it also facilitates sharing. Well, the challenge with that is under most circumstances, people are going to use Office IRM and rights management services as kind of an opt-in technology. Yep. So if I want to share protected content to you, but I want to make sure that nobody else has access to that, I'm going to go out of my way to go limit that protection. I'm going to add access control that just Simon myself have access to this content, and then you can't forward it, and you can't copy, paste, and do all these types of things, right? So that works good, but I have to consciously do that. If I want to share external, it's the same thing. I need to share it with somebody external. We're going to probably be using Azure Active Directory accounts to facilitate the key exchange, and so they'll authenticate with an Azure account, and that works pretty good. But again, I have to opt in to do it. So the challenge that we have, if you look at the stats, is users are accidentally leaking data. Quite frequently. In fact, one of the stats we have is approximately 60% of users accidentally send information or leak information to the wrong people or to the wrong device, etc. My view is that stat is probably pretty low. I can't imagine anybody being able to say, I never have accidentally sent mail to the wrong recipient, or I never put data on an insecure USB drive, unless the IT organization has really put their arms around this and deployed some pretty sophisticated technology. So what we want to do in Windows 10 is deliver functionality to deal with that accidental data leakage scenario. And so the functionality that we are kind of internally calling enterprise data protection, that's a internal thing. We'll come up with a fancy name.
Yeah, we need something a bit more producty.
We got some ideas. We got some ideas that we're going to toy with, but right now, EDP, as we're kind of calling it, Enterprise Data Protection, is this feature to fill in that gap between BitLocker and rights management services. And so I think the best way to describe it is kind of in terms of like a scenario, right? So if we think about the life cycle of data, right? Well, the beginning of the life cycle is when I'm bringing in a new device into a corporate organization. And so we have the concept of enrollment. So when I enroll my PC into MDM or onto the domain, and I have System Center Configuration Manager, I'm going to be able to receive EDP policies that will tell my PC how to behave, how to identify corporate data. And so, so that's the enrollment piece, receiving policies and also generation of the keys that we're going to use for encryption. So if we move into the next part of the life cycle, which might be data ingress, meaning data coming to the PC, well, one of those policies allows an organization to dictate, well, which locations on the corporate net or on our network are ours, right? So we have the internet, we have the intranet, and you're able to use a policy to say these are the servers or the network locations by domain, IP address ranges, et cetera, that represent locations where corporate data can come from. And then anything that's not in that policy is considered public space. And so then use EDP's ability to leverage this policy and use our networking stack to determine, well, what is the origin of the data that I'm receiving right now, let's say a corporate mail server or for a file server. If that server is considered one of those members of that corporate location space based on that policy, EDP knows it's going to apply persistent data encryption to the files as they come in. So as data coming in from corporate resources comes in, we automatically add file level protection. It could be for documents, files of any type, even applications themselves. So it really covers anything that gets persisted to the file system can be protected. So that's our ingress scenario. When we move to another scenario like data genesis, right? Data genesis, meaning creating new data, that can be kind of tricky, right? We have a policy that allows organizations to say any data created on this PC is always going to be protected. And in that case, it's real simple for organization, right? So, and that'll work for certain types, right? Some organizations do not have the concept of personal work on a work device. So real easy for them to set that up so that all data is protected. Where things can get a little bit more tricky is maybe on the other extreme, which is the BYOD scenario, where I have a PC that maybe it's personal, half the time, the other half I'm using it for corporate purposes. And so what we've done there is we've added in the Windows infrastructure itself, so in our architecture, we have things that we call common controls. And so common controls are UI elements that applications are able to take advantage of. And so what we've done is we've enlightened or enhanced using our APIs these common controls so that they know how to handle and identify corporate data versus non-corporate data. So one of those common controls, for instance, is the save as dialog that we see in almost every app that we use. So when I create a document with, let's say, Notepad or WordPad or Office, for instance, you'll notice there's a save as dialog. And so that dialog has been enhanced so it can enable the user to define, well, is this my personal information I've just created, or is this corporate information. Now, again, we think that that's a BYOD scenario where the user is going to need to make a decision. In the other extreme, the corporate provision device, you can use policy that always forces the data into a protected state. But that's kind of the data genesis scenario. And then on egress, where data leaves the device, we're able to maintain protection as the data moves off of the device. But this is where we use rights management services. Mm-hmm. So on egress, we can assume I'm actually sharing content with somebody. And so Windows is able to then apply rights management services, which is encryption that enables sharing of keys so that data can be decrypted by the recipient. That's where RMS joins or kind of is dovetailed with EDP, is for that sharing scenario where data is leaving the device and being sent via email or pushed to the cloud, as an example, maybe like Box or OneDrive for Business, et cetera. So it's a really robust end-to-end solution, and it will provide a level of protection that people typically have on their phones, mm-hmm. But have never attempted to deploy on their desktops. In fact, at TechEd in Europe just a couple weeks ago, I asked everybody in the audience, and there were about 3 sessions I did this in. Let's say about 800 total people amongst those 3 sessions. And I asked everybody to raise their hands. Who's using a solution like this on mobile phones? Everybody raised their hands, said, yeah, I use it on mobile phones. Who's using this type of technology on desktops? And out of 700 or 800 people, I think maybe 10 people, roughly, amongst all those sessions. So this fills a huge gap on the desktop. And on mobile, because the solution is baked into the system itself, I don't need to have the user switch contexts. Like mm-hmm. if you're familiar with Knox, I have to switch into the Knox container. If I'm using secure email, I need to go into the Good Email client or the AirWatch email client, right? You always have to switch modes to get protected content.
And that can be really jarring.
Oh, absolutely. Yeah. Because we bake this technology into the platform itself, I don't need to do any switching. Windows is just smart, right? Windows knows where data is coming from. Right? We know that's corporate or that's personal, and is able to make all the decisions behind the scenes, and the user really only in the case where we're creating new content will ever be faced with this fact that they have this corporate data protection working behind the scenes.
Yeah, it's very cool. And I see also on the slide you've actually mentioned that we're thinking about connectivity for when we're moving data around, so things like VPN as well, and that forms part of this whole story about about data protection, because we want to make sure that I guess when an app needs a VPN, the VPN is just there.
Yeah, absolutely. So we have like auto-triggered VPNs, and we've had that in Windows 8.1, and so that's great functionality. What a feature that people typically couple with this data loss prevention technology is a feature that prevents a application that's not considered corporate gaining access or having the ability to trigger the VPN. And so that's what this policy you're referring to does. And so what you can do is use our policies to define, these are the applications that we'll allow to auto-trigger the VPN and to access the VPN. So that might be a very small subset of the applications on the device. And so this has interesting implications from a malware resistance perspective, right? If I can say these are the trusted apps who can access the VPN, things that are on that list inherently, maybe potentially malware, for instance, won't have the ability to get on your network. Now, with that said, we want to be really careful about the malware statement we're making here. This doesn't mean that malware is unable to get onto your corporate network. Malware specifically designed to circumvent the system very likely could, but most malware probably isn't being designed for that purpose in mind. So you could say that this would block a lot of the malware we see today from that, but to provide the strongest possible assurance that malware can never access your VPN. This is not a technology to do that, but again, it will block most of the stuff that we see today. So it's pretty effective in that regard.
But as you say, malware is another area that we've been thinking about.
Yep.
And been thinking about the threat resistance, taking the feedback that these guys have been giving us to help us think about the way that we do threat resistance. So let's just talk for a little while about threat resistance.
Yeah, no problem. And I know I've talked a little long on some of the other topics, but we can probably shrink this down to the time that we have left. So there's a couple things that are going to be pretty interesting when it comes to malware resistance. And there's a much broader story that we're actually going to talk about next year. So we're only disclosing kind of 2 categories that we're focused on at this point. But again, we'll have a much broader story. But what we do disclose at this point is actually pretty interesting. And the first thing that I think is worth talking about is something that we're calling internally, again, not a branded name, but enterprise lockdown. And so enterprise lockdown brings The type of technology that we see on phones and some mobile devices, Windows Phone and iOS devices being a good example. We're going to bring that type of technology to Enterprise Edition of Windows. And so the technology we're talking about is, if you're familiar with a phone, something you've probably enjoyed on your Windows Phone or iOS devices, you've probably maybe never experienced malware on it. And why is that the case? Well, the reason why is because every single app that ends up on these devices goes through a pretty extensive vetting process. The vendor is vetted, so there's some safeguards there to make sure that we have legitimate vendors participating in the app ecosystem. The apps are submitted and vetted through a process of automation, and in some cases even humans actually are taking a look at this, or taking a hands-on look at the applications being submitted. And so this filters out the vast majority of malware entering in to these store ecosystems. And of course, the store is the only way to get access to binaries on Windows Phone and iOS example. And so it's a pretty good system, and so we've seen great results from that. Now, we had that technology on Windows Phone. We even had it on Windows RT in Windows 8.1. And we're going to take that technology and we're going to put it on Windows Enterprise Edition for Windows 10. Now, some of you might be going, well, why isn't it on every edition of Windows? Well, the challenge we face with this technology is it requires control of the app ecosystem. And on the Windows platform, we have this long tradition of an uncontrolled app ecosystem. And most of the applications that people run on the Windows platform do not come through a store process. They come directly from ISVs, websites like downloads.com, and the tens of thousands, if not hundreds of thousands of other websites that will distribute good and in some cases even very bad malware to your PC.
But this is the reason we have the 4 million or so desktop applications out there. There are literally millions of applications on Windows because of that reason. But it's also, therefore, a potential area for people to exploit.
Absolutely, absolutely. And so what we're trying to do is we're trying to take a graduated approach towards moving the entire Windows ecosystem towards a controlled app ecosystem. And we can't do that overnight. We've done it on phone, right? Windows Phone was a new platform with a whole new app ecosystem. Easy to do that when you start a brand new platform. We could do the same thing with RT. For Windows, it's a little trickier because if I lock down this PC, that means that you can't get your favorite applications in the ways you're used to. Mm-hmm. So for enterprises, we're going to offer this technology because they use very controlled ways of getting access to their apps. They work with a few vendors in many cases. A lot of them come internally, et cetera. And so what we'll do for commercial enterprise customers is they will have access to a signing service. And so what they will be able to do is they will be able to sign any of their line of business applications using a very special signing process. It's not just that the binary is signed. It has to be signed using a very specific process, and that process is ours. And so enterprises will gain access to this tool. They can sign all of their line of business applications. In parallel, ISVs are being encouraged very vocally to sign all their applications using this process. When they do that, those applications can be put in the Windows Store. So today, Windows Store is just universal apps. With Windows 10, it's going to be universal apps as well as Win32 apps.
That have been signed.
That have been signed using this process. And so that will be a much richer, more vibrant ecosystem than we've had in the process. And so once we hit critical mass in the store with ISVs and signed apps in that space, then we futuristically can kind of move the knob away from enterprise and maybe introduce that to a broader range of consumers. But for now, we're just not going to be there for some time. And so anyway, ISVs will be able to sign their bits. Line of business apps can be signed by the enterprises themselves. Enterprises can still gain access to all these apps in the store. And they have a pretty high assurance that they're not going to see the volume of malware that they're used to. In fact, you could argue, if we look at the malware that we see today, you could argue that maybe 99+% of the malware that we see in the ecosystem today can be mitigated with this type of technology all by itself. And so it's very effective in its ability to block the malware that we see in the PC ecosystem today.
Awesome. It's going to be, it is, as you say, it's going to be very effective, and particularly it's going to be great for enterprises to have that level of control. Being able to reduce the attack surface for malware obviously allows people to reduce the cost of running those systems as well. So it's kind of a super cool thing to be doing. Kind of brings us to the end of this particular section. Kind Coming up in our next section, we're going to be talking about Internet Explorer, and we're going to be doing that with Fred. But keep the questions coming in. We'll try and get them answered inside of the Q&A. We'll see you after another 10-minute break.